Okay, thank you everyone for coming. Welcome to XML London 2016. If anybody's ordered a set of conference proceedings, they're at the reception registration desk, available for you to pick up later. The proceedings are also online for free as a PDF document, and are available at this address, and we've got our Sparkle and RDF data endpoints there. To get onto the internet, the details are over there, Wi-Fi self-service using the event code XML. And just another point that there is a demo jam later. Basically, it's a fun event. You can win stardom in the XML and RDF world. There are 10 slots. You get 5 minutes to demo whatever you want to demo. Something cool, something original, something funny. And the winner is chosen by the audience at the end. Based on basically a scientific clapathon. So yeah, but first up today, we have Abel Braaksma, who is a member of the XSLT 3 working group, and is the author of the XSLT 3 processor, which works on the .NET platform, but also now, I believe, works on Mac OS just about. Abel will probably tell you a little bit more about that. But yeah, so he's up first. Are you ready? Yes.
All right. Hold on a second. Make this ready.
Okay. You good? Okay.
Okay.
Thanks.
Sound
Take it away.
check. Check. All right. Good morning, everyone. You are going to hear a little bit about streaming, and then in more particular continuous streaming, and a couple of other goodies. What you're looking at here is the simplest continuous stream that I could think of. That is quite easy to fathom, I think. Just a feed of time. This style sheet that you see processes XML with time elements, and then it displays them as HTML. That's all on continuous streaming. So let's continue. I will be talking about what I think continuous streaming should be. I called it in the paper uninterrupted streaming, but I found that, well, too hard to pronounce, so I make it continuous streaming. We'll talk a little bit about the new components for initializing a style sheet with streaming, and we will look at some caveats that you will come across when you will be processing these kinds of streams, and that you have to be aware of. So let's go back a little bit of what streaming is again. Maybe it's good for just one moment. How many people are in the room that work with XSLT? Oh, that is a big fan base. I'm then not going to ask about XQuery. How many people of this 90% hands that I saw have ever attempted or worked with streaming in XSLT? 2, 3, 4. I didn't see you raise your hand, Michael.
Well, I just make it work.
You never attempted. In XSLT 3, when we started out with XSLT 3, we found out that when you have very big XML documents that don't fit into memory, you cannot process them. To make that work, we defined certain rules in the language to allow such large documents to be processed without having to read them completely in memory at once. And the way the world usually looks at streaming is like a video stream, like a tennis match, football match. And such a live match or feed is not downloaded at once, but is downloaded a chunk at a time. A similar thing happens when you do XSLT streaming. You don't download or process the whole document at once. You do it piece by piece. The difference between streaming and continuous streaming, apparently according to Wikipedia it's also called true streaming, is that with continuous streaming there is not necessarily an end to the stream. The time stream that you saw in the beginning starts at the beginning of time, ends at the end of time. Depending on your definition of the end of time, that is quite a long time. And let's call that never-ending continuous streaming stream. Now, how can you deal with streaming in XSLT? I saw all people raising hands, or almost all people that work with XSLT. I hope that the other 10% knows a little bit about XML as well. Normally, if you work with XML, you have to load the whole document in memory so that you can select things from the end and beginning and back and do some nice queries. Now, when you do streaming, you don't have that option, because with that time example we saw in the beginning, if you would want to know what the last time is and then want to do back what the first time is, you will have to wait until the end of times. So you simply cannot do these things. Now, to define that in XSLT proved to be a bit of a challenge, because XSLT, as used in XSLT 1 and 2, looks at the document as a whole, looks at the document as a DOM instance, and that has a beginning and an end. You always need these end tags to appear at some point. When you're using streaming, you're actually kind of doing the same anyway, except that you assume that these end tags will appear at the end. You're just not reading all the way to the end, and that means that you may get an error by the end of time. XSLT is a functional language. It's also called a declarative language. As a functional language, and that's actually the second item here, you have an input document being mapped to an output document. Your XSLT style sheet that you have written contains rules that say, take this document and process it with these rules, and you get this output document. Give it the same document twice, you get the same output document. That is called determinism. With streams, it's a little bit different. Again, think about the time stream you saw. Suppose I would call it up again. Would you think it would still show 9:00 in the morning? If I fire it up, we can have a look. I think you can pretty well guess what it should do. In case you were wondering if it was still running, let's see at the bottom. Yeah, still running. Now, let's load it again. I don't get the same stream again. I have the same URI, but I get different data. Normally with functional languages, same URI with a doc function means that you get the same document back. With streaming, not so much. In other words, we call this, that streaming is non-deterministic. Call the same stream twice in one style sheet, you cannot guarantee that you will get the same data. People that use XSLT and use the doc function or the document function, they know that if they call it once, twice, 10 times, doesn't matter, because you get the same document again and again. It'll probably not even be loaded again. In fact, your processor is not even allowed to load it again, because suppose that in the meantime the document has changed. But it has to return the same document. All right. Now, let's look at some ways to tell the processor that you want to stream such big or continuous streaming documents. Maybe we should actually get rid of the word document, because document kind of suggests a beginning and an end. But I don't have a different term there. Maybe we should just call it a stream of data. When you initialize a style sheet in XSLT2, you give it an input document, and that input document is kind of all you can give to it. It will be processed, and you get the output document. And if you try to access that document from a global variable or from a template match, it will always be the same document. Not so much in XSLT3. In XSLT3, when style sheet is initialized, we don't call it initializing anymore, we call it priming. When it's being primed, we have an initial match selection, which we will look at shortly, and a global context item, which we'll also look at shortly. Back to XSLT2. You give it a document, and it is processed with an XSL template. That's the way the world used to turn around XSLT. In XSLT3, we don't talk anymore about an input document. We talk about an initial match selection. This initial match selection is what you give the processor when you are initializing the style sheet and you run it in the default mode, or any other mode for that matter. This match selection can be anything. Normally, in the 2.0 times, you just process XML, and if you wanted to process something else, you had to call unparsed text. Now you can give it any kind of item. You can give it a document node, just as with 2.0. You can give it a string, an integer, a map, an item, an array, if your processor supports XPath 3.1. You can even give it a sequence of documents. You can give it an element or an attribute node, though I don't think there's too much to do if you just give it only one attribute node. You could even give it an empty sequence. So again, there's not too much to process if you do that. But all these things are allowed. The fact that the natural match selection is important here is that if you initialize your style sheet, this is the only way, the only feed, the only data you can give that can be streaming or non-streaming. From the point of streaming, the only thing we can stream with XSLT at this moment, or with the current specification, is XML documents, or XML nodes, more specifically. We cannot stream, unfortunately, strings, unparsed text, or unparsed text lines, new functions in XPath 3.0. They are considered stable, so calling these multiple times will simply give you the same document. They are not supposed to stream your data.
Can I just interrupt there, Abel? You could potentially pass it an initial match selection, which is an infinite sequence of strings, couldn't you? But XSLT doesn't call that streaming.
You could, but a sequence has a beginning and an end in XSLT. It has a length.
Because of things like position function, like
Yeah.
last function. Yeah.
So an infinite sequence, well, your processor may be able to support it, but if you ask the length, like last, then you're lost.
Okay.
Was I writing here? Oh yeah. So initial match selection, let's say this is your initial match selection. It's very simple hello world document with a root node and one child node. Actually, not one child node, but potato, potato. This is one way you could process this. I just added this example to show where an initial match selection is actually used. The XL mode declaration on top is a mode declaration without a name, which means it will be the default mode. And the default mode is the mode it's called if you don't specify a named mode. A mode can have a name just as an XSLT2, and in XSLT3 you can specify that declaratively with an XL mode declaration. Then, if you call the default mode, the first XSL template here will match the foo item, the root element. And it then, well, it outputs that it finds the foo element. We saw that in the previous slide, there is a foo element. And then you will apply templates on the child nodes. In this case, you're only selecting the bar child nodes. And this, at that point, sets a new current match selection. Then we have another template which matches this bar. Anybody working with XSLT on a regular basis would expect this to output foo found, bar found. Not rocket science there. But what's important to realize is that you have the initial match selection, which will essentially go, or is applied to all matches that it finds. And once it gets into one of those matches, you can do apply templates which changes it to a current match selection. The initial match selection is only the one you have at the very beginning. And once you continue processing, you start a new match selection, which I believe, I'm not entirely sure, but in the spec is also called the current match selection or the current context item. So what's then the global context item, that other thing? If we have an initial match selection, why do we need something else? Well, recall that in XSLT2, when you throw a document at it, and you have an XSL variable, a global XSL variable, you can access that input document, just like that, with the dot. Not everybody uses this kind of accessing the input, but it's possible. I think it has been possible since XSLT1. In the previous slides, I explained that initial match selection can be any sequence. Now, if you have this kind of XSL variable, if you have a sequence of, let's say, 10 documents, what document would it have access to? The first one, the last one, all of them? But if it's all of them, what is dot selecting? Because dot can only return an item, a single item. So we introduced the global context item. The global context item is the item that is accessible by global variables or global parameters. Essentially, it is, you could say in a way, it is there for backwards compatibility or for people that just like to use this kind of global variables. It can be any item or absent. So the same change that we apply to the initial match selection is what we change with the global context item. It can be a string, it can be a map, it can simply not be there. It can be disjoint from the IMS. IMS, initial match selection. Disjoint, I mean that in XSLT2, again, you gave it a document, and the global context item and the initial match selection were the same item. They had the same identity. In XSLT3, that's not necessarily the case. So it may depend on your processor whether or not they are set to the same node, if they are indeed the same document, or whether these are two copies of a node with a different identity. That was actually my next point. So why would you use the global context item? With some recent discussion in the working group, I actually started to question why one would necessarily use it, because there are different ways of getting this kind of data. But you can use it to set some configuration settings. I think it's clearer to use external documents, and I think the XSLTs I've seen in the wild usually use that kind of approach. One of the biggest limitations with the global context item, there's only one way to access them, and that is in the global variables. So what are the differences? I would like to emphasize that the initial match selection and global context item are not anymore related as in XSLT2, they are unrelated. Initial match selection is a sequence, global context item is one single item, or empty. Typically, from the 2.0 time, initial match selection will be your input document, and the global context item may be the same, but doesn't have to be. The initial match selection, maybe this is the global rule to remember. Initial match selection is the thing you transform. Global context item is for auxiliary data. So back to streaming. Now that we know kind of what initial match selection is and what a global context item is, we could say, and I'm running a little bit ahead of myself here, and I am invalidating some things that I actually wrote in my paper. The global context item cannot be streamed. You might question why that is, and that is a relatively long and complex discussion we recently had in the working group. But essentially it is that if you have these global variables and they have to access a global context item and you have to stream it, then what happens if you have two global variables and they both access it and they try to consume that tree? They go through the time that you just saw earlier, and you use one variable earlier in your style sheet and the other variable later. What are you returning? And the variables are essentially not stable anymore. There are currently in the candidate recommendation rules to actually stream the global context item, but these rules are such that you cannot go past the root element. So you can call it streaming, but you cannot actually move. You cannot go into the stream. So there's actually a public proposal right now. That's why I'm there to say it with a little star here. I'm not sure if it will be accepted by the working group at some point or not, but it is very well possible that in the end it is not possible at all anymore to stream the global context item. So feeding your style sheet a stream node, you do it through the initial match selection, which is probably what you already saw coming. And the initial match selection can, of course, also be a non-stream node, just in the usual sense. And if initial match selection is not a node, we had that before, if it's just a string or a sequence, even a very long sequence, it is not streamed. And this may be a little surprising, but we have an XSL stream instruction in XSLT 3, which is the equivalent of the doc function, but then for streaming. Where the doc and the document, the document function can accept a range of documents and return a sequence of documents. XSL stream cannot. So the only way to have multiple streams being processed by your style sheet is by using the initial match selection to give it a collection of stream nodes. Maybe collection is not.
XSL stream inside a loop.
Sorry?
You can put XSL stream inside a loop.
Yes, of course you can. I mean, there's always different ways around it. But if you, with the, there can be differences in the ways a stream is being processed, especially considering the non-determinism. And when you feed your style sheet a sequence, it could be processed in parallel at once. Still, there are other ways to do it from the style sheet, but we don't have an instruction that says, like having collection, that returns a collection of stream documents. But I believe the initial match selection allows it. Whether or not the processor supports it is a different thing, of course. That can be just a matter of time. So let's see at some ways to initiate streaming. If you use initial match selection, you have to set the XSL mode to streamable equals yes. And I call this API dependent because whether or not when you call your processor on the command line, you feed it the document, your processor has to somehow know before it starts reading your document that it has to be streamed. It's possible that your processor has some command line arguments to make sure that that actually happens. By using the XSL stream instruction, that is API independent because this forces your processors to stream the URI. Another alternative is to use the initial function. That's a new way of invoking a style sheet. In XSLT2 you could not invoke a style sheet with just calling a function. Now you can. And a function can be declared streamable, and if it's declared streamable it can also accept the streamed node. Again, this is API dependent for the same reasons as initial match selection. And of course there's always the way through extension functions or instructions to start streaming. And I believe Saxon has a function called Saxon stream, for instance, which is one of such extension functions. So let's look at what streaming, or also continuous streaming, actually does, or what you have to look out for when you work with your style sheet. Let's look at one of the biggest, well, I think one of the biggest issues with streaming in general. I started out with telling that XSLT is a functional language that is essentially a mapping from input document to output document. To get that kind of mapping, your processor processes your input document, and if you want it to be serialized, it can be serialized at the end. It doesn't have to be at the end, but in functional languages, serialization and things like that are usually postponed until all the other calculations are done. That's why I called it here monadic for people that work with Haskell or something similar. I say is monadic is not entirely true. It can be monadic. For Excel it was important because we implement Excel in a functional language, so we have to deal with these side effects. If you have again this mental image of input document, output document, if your input document is very, very long, like this eternal time or a Twitter feed or whatever, then you will have to wait for that output document. But how long? Okay, you can sit behind your desk and wait, you can break the process, but if you break your process then it raises an error and you don't have a document at all. Because XSLT is defined that if an error occurs, everything is rolled back. I call this buffering issues because the only way to get those continuous streams to do something and not to have to wait indefinitely before it is finished, your processor will have to buffer something and have to output intermittent data so that you can actually see the result while you are waiting for the end. The second point here is the input-output mapping invalidation. I think I mentioned that a few times already. There is, with streaming input, there's no real relation anymore between the input and the output. The input document has the same URI, but the output document will be different each time you invoke it. A little bit of an implementation detail, final result tree versus temporary result tree. If you say you have your template, you have a variable in that template, and in that variable you do apply templates, and then later you don't use that variable, then if your processor would be buffering and writing out this data from the variable, you run into a problem because your disk will get full of all the data that's in the variable, but in the end, for some reason, you don't use that variable. That's why we have the definition of final result tree versus temporary result tree. A temporary result tree is the tree used in such a variable and in some other occasions and can never be serialized while it's being processed. By the time the processor knows for sure that whatever you have been processing is actually final, it's not going to be reprocessed anymore, we call it a final result tree, and we can start writing to the output stream. When you're writing your style sheet and you think like, hey, I'm writing here a value of, why am I not seeing it? It's maybe because you are inside the temporary result stream and your processor has not evaluated that variable. Yeah, well, if your stream is really continuous and never ending, then you will probably have to interrupt your process at some point. If you interrupt it, you don't want your process to throw an error, you want it to neatly close in some way. Another challenge with streaming is if you have it in a pipeline, where you have one phase for some transformation, next phase for some transformation, maybe you add some other documents or some other processes. When you do that streaming, and you have again this continuous streaming, then of course this whole pipeline and every single step in it has to stream as well, and has to be able to maintain that. I checked whether Xproc supports streaming. Xproc from itself does. From a quick search I only could find QuicksProc. I haven't used it myself, but it says it supports a streaming pipeline. Dealing with errors, we will look at that in some following slides. I give you a moment to look at this, and I give my a moment to drink this. Okay, so here we have somewhat different style sheets than the time style sheet you saw earlier, but it essentially does the same thing. In this case, I anticipate that an error may occur. An error in XSLT3 can be called with XSL try catch. In XSLT2, there was no such thing. And the rule with try catch is that if something fails here, and you get into the catch, and the catch is returned, and not what happened here. So let's do this little mental exercise with the eternal time stream again. We call it continuous XML. We start with XSL initial template, which is another way of starting a 3.0 style sheet. We start streaming the continuous XML. We apply templates on time. Here's the matching template. This template has to be streamable, which we actually say here, streamable equals true. We match the template time, we output emphasis, title, current time, and the value. And this runs and runs and runs and runs and runs and runs and runs. And then at some point, boom, error occurs. Now your processor has to roll back the XSL try. So what it has output all this time has now to be rolled back, but what if you already sent it to your browser, or you sent it to a database, or what, 1 minute? Huh, okay. Well, then you feel it coming, it will be too big to roll back. Since you already wrote something to this, you cannot roll back. To tell the processor that you don't want to buffer this, we introduced rollback output equals no. In this particular scenario, we don't expect too much errors to occur. The only error that is likely to occur is right here, that you can't find the document. That error we want to catch, and at that point nothing is written already. So we tell the processor, we know what kind of errors to expect. After that, you don't have to buffer. You can buffer and flush and whatever. All right, then I skip this one, which may be pretty obvious anyway. Well, we didn't get deep into the actual streaming rules. because this talk is not about the actual streaming rules. Often when people hear the word streaming in XML, they think it is very difficult. And if you look at the discussion we've had in the working group, yes, you could say it is, in theory, and the deeper theory behind it, very difficult. But the rules we've come up with are actually really not that hard to fathom. In fact, you just have to think a little bit simpler. You don't make your style sheet too complex. So the main thing to remember is that there's the one downward select rule within any construct. If you are going to attempt streaming, I suggest you check out, you can Google for it, 10 rules of thumb with streaming, or the streaming design patterns, which I presented 2 years ago already, which shows typical XSLT2 scenarios supertransposed on an XSLT3 streaming scenario on how to go from one way to another. And the 10 rules of thumb is just forget all the complex streaming rules, just use normal British English to make it understandable. Well, and keep it simple. Oh, I was pretty close to the end. So, as a conclusion, we could say, from what we've seen, that continuous streaming is actually possible, but there are some caveats that you have to think about, and of course your processor has to be able to deal with it. There are clear differences now from XSLT2 when it comes down to the global context item and the initial match selection. And only the initial match selection can be streamed. We have seen a couple of new different invocation methods. Some of them came from the wish to be able to stream, and some of them came from other wishes. That's it. Just before you start clapping, this is the oldest bond. This is a 366-year-old stream of interest data.
It's very good for my presentation because it's all about bonds.
Oh, great. All right. Thank you.
So we have some time for some questions for Abel. Anybody have some questions? Stephen?
So I don't know anything about XSLT streaming, but when we were designing CSS, they designed it to be streaming against my wishes, and so some of the selectors were not allowed because you couldn't do them streaming. And I said, well, just mark the ones that you can use for streaming and leave them all in, so that then you couldn't select anything. But does streaming restrict what you can select?
Yes.
Yeah. Okay.
It is CSS, you may then recall, only has forward selectors.
Yes, exactly.
And you never have a backward selector.
Right.
You cannot say make something blue if the previous one is red.
Right.
You can now.
Sorry?
You can now, but.
Okay, yeah, but in the original CSS design you could not. And that's actually the same with XSLT streaming. You can only move forward, and any data you want to use later, you will have to buffer with an accumulator or something.
And so are those selectors marked as not suitable for streaming? Or
no.
you have to discover it yourself?
And yes, no, you don't have to discover it yourself. There are rules in XSLT3 that say, for instance, that previous sibling is never streamable. We call that roaming.
To answer the question another way, you have to declare a mode as being streamable. If you declare it as streamable, then all the templates in that mode have to satisfy certain syntactic restrictions.
Syntactic, so it's checkable.
So they're statically checkable,
Right.
but you obey the rules.
Okay.
So, any other questions? Or was it really that simple?
Okay, thank you, Abel.